Imagine waking up at midnight to find the sky blazing with light, as if the sun had risen hours too early. Fiery colors dance above your head, the air feels charged, and suddenly everything goes dark. Power grids collapse, trains halt in their tracks, devices spark and fail, and entire cities plunge into chaos. This isn't a scene from a sci-fi movie. It's a reality that has struck our world before, and one that could strike again. These are solar storms, colossal cosmic eruptions carrying enough energy to disrupt an entire planet and cripple the very foundation of our civilization, electricity. In March 1989, a massive solar storm erupted, with a size equivalent to 36 times that of planet Earth. It emanated from the Sun and moved through space until it collided with Earth's atmosphere, causing a red aurora that stretched at night over a distance that covered almost the entire Earth. In fact, it was so intense that some residents thought a nuclear bomb had been detonated in a nearby area. Industrial facilities in the northern and southern regions malfunctioned, and power grids were completely cut off. Even electrical transformers were destroyed. These events caused a power outage for 6 million inhabitants of the northern areas for 9 consecutive hours. Although it wasn't the largest solar storm to have occurred, it caused the largest historical power outage in the region because people at that time had already come to rely heavily on electricity. Going further back in time to May 1921, in the city of Karlstad, Sweden, employees at the Land Telephone Centre noticed that devices were malfunctioning and emitting smoke. A short while later, just before dawn, electrical cables began to catch fire one after another. By sunrise, the entire system had turned to ashes. The solar storm that occurred at that time caused even greater losses. A massive electrical spark erupted in the telegraph wires of the railways, which in turn propagated high-voltage currents through all the wires, leading to 3 huge fires at train stations in America, Canada, and Sweden. Let us go back even further to September 1859. The world's population woke up that day to a bright light, and workers went out to start their daily routines. However, it was later revealed that the time was actually midnight during the incident that later became famously known as the Carrington event, named after the astronomer Richard Carrington who recorded the event. The solar storm caused telegraph devices to emit electrical sparks that led to the electrocution of some workers and burned papers near the electrical devices. The electrical current was so strong that it nearly melted platinum wires. Some who witnessed the event said that waves of flame were emanating from the electrical circuits. But away from the electricity, the sky was brilliant, illuminated, and filled with the beautiful colors of the aurora borealis that spread across most of the Earth. Some people enjoyed the spectacle, while others were terrified and thought it was the end of the world. The glow that occurred had the power of 10 billion atomic bombs, in what is considered the most massive and violent recorded solar storm to strike Earth. Solar storms are a recurring phenomenon and may occur approximately every 50 years. But the severe storms that affect the entire world are very rare, like the Carrington event, which might happen every 500 years. But what are solar storms, exactly? Solar storms are a physical phenomenon that occurs due to magnetic fields generated by the movement of electrically charged particles like protons and electrons. On the Sun, its magnetic field is formed by the movement of plasma within the Sun's core. When this plasma rotates, an intense magnetic activity known as sunspots is created. The magnetic field around these spots is often irregular, as if it is being stretched and twisted. Due to the intense pressure it is under, it releases energy in the form of plasma in what is called a coronal mass ejection (CME). This ejected plasma projectile, mostly composed of protons and electrons, increases its speed until it reaches thousands of kilometers per second. It typically covers the distance between the Sun and Earth in 2 days. By the mercy of God Almighty, He provided Earth with a magnetic field that acts as a shield against such phenomena. When a solar storm reaches Earth, it merges with our magnetosphere and is directed toward the north and south poles. There, it begins to interact with the positive and negative particles in the atmosphere, colliding with them and releasing photons of light, which we later see as the beautiful aurora borealis. But the problem is certainly not just pretty lights for us to enjoy. Sometimes the sun emits plasma projectiles resulting from multiple sunspots, not just one. These projectiles are often of enormous size, with diameters reaching up to 37 million kilometers, and thus contain huge quantities of plasma and move at tremendous speeds. Although the magnetic field, as we said, deflects these rays toward the poles, the force and speed of the projectile can distort Earth's magnetic field into the well-known shape of a tail. In this shape, the radiation is unleashed with maximum force and speed possible, and when it reaches its peak, it begins to reflect from the atmosphere down to the Earth's surface. This is where the effects of solar storms begin. The first thing you would notice is that devices in your home working at that time would malfunction, if not burn out completely. If you had money in the bank, you wouldn't be able to withdraw anything because all banking transactions would be halted. If someone is traveling on an electric train, the train would stop wherever it is. Water would be cut off in most parts of the world because lifting pumps operate on electricity. And if someone, God forbid, is working in a place with high electricity, they could, God forbid, suffer an electric shock. Even the bigger problem is that hospitals themselves would not be able to receive cases because life support devices would be down. This terrifying scenario almost happened in July 2012. A tremendous solar storm, the size of the one that caused the Carrington event, reached us. Due to its force, it was named the impactor storm. By God's grace, Earth narrowly escaped this storm. Specialists say that a storm like this, if it had actually hit Earth, would have been catastrophic by all measures. In fact, the entire Earth would have spent long years repairing the consequences of this storm. The problem wouldn't have just been a matter of time. The cost of fixing the resulting problems would have exceeded $2 trillion. The reason a solar storm has such dire consequences for Earth is that we almost entirely depend on electricity. This is unlike in the past, when people enjoyed the aurora borealis without much fear of the consequences, because the world wasn't heavily reliant on electrical circuits like today. And from the mercy of God, praise be to Him, that solar storms, no matter their strength, do not directly affect our human bodies. Their effect on us is only through the emitted X-rays, and even these have a minimal impact. And if one wonders what would happen to an astronaut outside Earth's magnetic field during a solar storm, even they wouldn't be significantly affected due to the protective design of the spacesuit. In the end, there are studies now saying that during the next century, there is a high probability of a solar storm occurring. Although specialists disagree on its severity and potential impact, they are still continuing their research on this topic earnestly. They are even trying to find a way to determine the strength of past storms, and thus predict the strength of future ones so we can know their potential impact on Earth and take our precautions. But what precautions can we even take? In truth, no one knows exactly what the impact of the coming solar storms will be, and that's because we are already starting to take precautions. These precautions are represented in studying the sun and determining the expected timing of a solar storm. More than one specialized center now monitors sunspots, based on which they determine the strength of storms, when they might happen, and when they might reach Earth. On the other hand, electrical transformers are now being developed to withstand higher power loads, and weak transformers are what we need to shut down completely before a storm hits. Satellites are now beginning to be protected with insulating layers to shield them from solar projectiles, especially since we need satellites to monitor the sun's activity. Now there is a specialized center called the Space Weather Prediction Center, whose function is to give us warnings about expected space phenomena that could affect Earth. Which of course includes solar storms at the top of the list. If we succeed in all these steps, then we might be able to protect ourselves from solar storms. Living without electricity for a few days on our own terms is better than living without it for long years against our will.